Lesson 19.5, Task 2. Fit a quadratic function to data by hand. When the points on a scatter plot appear to represent a quadratic relationship, you can determine a function that models the data. You can do so by estimating the vertex and a second point that is visibly close to the pattern of the data. Those 2 points can be used to write a quadratic function in vertex form. The scatter plot shows data points that roughly follow a parabola. Find a quadratic function that models the data. All right, so you can see a parabola here. If you were to sketch that curve, it is upside down, so we know that it is negative. And we can see certain points here that represent this model here. So we can look and see that 2, 4 appears to be the vertex. It also has points 0, 0, 1, 3, 3, 3, and 4, 0 that are easy to determine what those points are. So let's think about that as we try to write an equation for this quadratic function. So it says, what point in the scatter plot appears to be the vertex? Remember, the vertex is the turning point. In this case, it would be the highest point since it's upside down. So 2, 4 would be the vertex. Substitute the coordinates of the vertex for h and k in vertex form of a quadratic function. All right, so we know that y equals a times x minus h squared plus k is vertex form. And if we plug in 2, 4, that gives us f of x equals a times x minus 2 quantity squared plus 4. So this represents 2, 4 as the vertex. Now it says you can use a second point that represents the data, such as 1, 3, to substitute for x and y in vertex form of the equation and solve for a. All right, so you can see y equals a and then x minus 2 squared plus 4. So I said y, f of x is the same as y in function notation. So if we got x and y, if we use another point to substitute for x and y, we can solve for a. So they chose 1, 3 off the graph above. And we saw that already. We've seen that 1, 3 looks like a point on the curve. So they're going to use 1, 3 to find a. All right, so when you do that, you have to do order of operations. 1 minus 2 is negative 1. Negative 1 squared is 1. So 1 times a plus 4, then subtract 4 from both sides. We get a is negative 1. So all we'd have to do is take this number, substitute it in for a, and this would be vertex form. All right, so it says, what is another point besides 1, 3 that could have been chosen to represent the data? So 1, 3, 2, 4, or 3, 3. So if we look, 2, 4 is the vertex, so we can't use it. We used 1, 3, but we also could have used 3, 3, because that's another point that would have worked. Would you get the same answer if you chose that point? Yes, it would still represent the same equation, okay? All right, it says, what value is found for a? Does it make sense that the value of a is negative? Select the correct words to complete the statement. It does make sense that a is negative because the parabola opens downward, okay? So when it has a negative, that we know that the parabola is upside down. So the data can be modeled by the function f of x equals negative times x minus 2 squared plus 4. So that's how you would write an equation given a graph. All right, that's all for task 2. If you have any questions, let me know. Lesson 19.5, task 3. Fit a quadratic function to real-world data. For the projectile motion function, h of t equals negative 16t squared plus v sub o t plus h sub o, sometimes values of v sub o and h sub o are not known. In such cases, you may need to solve a system of equations to determine a function that models the data. All right, by now this function should look familiar because we've used this in several other lessons that we've worked in. Okay, so now they're saying that the v sub o and h sub o may not be known. All right, so in order to find those, let's see how we can use our table of values. So it says a coin is tossed off a bridge into a river. The height h in feet of a coin above the river at time t in seconds is shown in the table. Find a quadratic model for the data. So that we see time in seconds, so we got 1, 2, 3, 4, up to 5 seconds. And this would be height in feet of the coin above the river, okay? All right, so it says, do the data in the table show a quadratic pattern? Select the correct word to complete each statement. All right, so if you're not sure about this, you could do your first and second difference that we just learned in the last example. You also could use your calculator to look at the scatter plot. So if you want to look at the pattern and see if this looks like a quadratic model, go to Stat and go to Edit. So we're going to enter our points here, and we're going to put in 1 through 5. All right, so that's my x values, and then I'm going to put my y values, or in this case it's h, but I think of ordered pairs as x's and y's. So we've got 3, 7, 3, 300, 195, and 58. All right, so that's the numbers straight out of the table here. Now, if I hit graph, it's not going to show up anything unless I turn on my scatter plot. So all I've done is enter points, but here where it says scatter plot, if you go to second, Y, and see how it has the stat plot is turned off, hit enter, and then hit on. And what that does is put the dots on the graph. So it's pulling from L1 and L2. That's where we put our X's and Y's. And it's going to show just a dot on each place that we have an ordered pair. Now, this is showing a 10 by 10 window. Look how big these points are. So if I want to see points that go up to 414, this is my Y value. I'm going to have to make my Y's go up that far. So you got to go to Window, and I'm going to change my Y value, my maximum, to bigger than 414. So let's change it to, say, 425. All right, if we go by a scale of 1, it's going to be itty bitty. It's going to be hard to see. So let's change our scale to a scale of, I don't know, we'll change it to a scale of, let's do 20. And see what it looks like. Okay, so now you can see this curve here. And again, if you did a reflection, you'd have the other side of the curve here. So you can use your calculator to see if this is a quadratic function or not. And we're going to use our calculator in a few minutes to even write an equation for us. So we're going to say the data shows a quadratic pattern because the second difference is constant. The shape of the scatter plots appear to be a parabola. All right, so it says the values of V sub O and H sub O are unknown, so substitute 2 data points into the projectile motion function to create a system of equations. For example, you can use 1 and 414 and 3 and 300 from the table. All right, so all they're doing is substituting your X and your Y into the equation, and then substitute your X and Y into the same equation again. This creates a system of equations. Remember, a system just means 2 or more. We did that in a previous unit, and you can solve for the values that you need using that. All right, so it says, does it matter which 2 data pairs are chosen to substitute for X and Y when created the system of equations? Select the correct words to complete this statement. All right, it does not matter which 2 data points you choose because all of the points satisfy this equation. All right, so if they're on that curve and they create that parabola, you can use any 2 points you want to set up your system of equations. And you should get the same answer. All right, so it says solve the system. All right, if they subtract then that means our h sub o's disappear. That means we only have one variable left. You solve for v sub o and get 7. So divide both sides here by -2. -14 divided by -2 is positive 7. And it says, what does v sub o equals 7 mean in the context of the situation? All right, so the initial vertical velocity of the coin is 7 feet per second, and the coin was tossed up. The initial height of the coin above the water at 0 seconds is 7 feet. The initial vertical velocity of the coin is 7 feet per second, and the coin was tossed down. All right, so we know we tossed the coin up, and the initial vertical velocity is 7 based on what we found right here. All right, so now it says substitute v sub o equals 7 into one of the original equations, one of your system of equations, plug it in, subtract 7 from both sides, and that gives you h sub o is 423. All right, so what does this mean in the context of the situation? Well, if you remember the equation, h of o is at the end of the equation. So that's going to be, this is going to be your y-intercept, okay? So we've looked at that in previous lessons as well. So the initial vertical velocity of the coin is 423 feet per second. The initial height of the coin above the water at 0 seconds is 423 feet. The highest point that the coin reaches is 420 feet. All right, so remember the y-intercept, that's your initial height, okay? So that's when the water is at 0 seconds, then it is at 423 feet. All right, so this is just being able to read and interpret the information given. All right, so a quadratic model for the given situation is h of t equals -16 t squared plus 7t plus 423. How did they find that? They took the 7 and the 423 and they plugged those into the original function that we started with. The only difference is we had the missing values. We didn't know what v sub o or h sub o were, so that's what we did, was solve for those two values so that we could write this quadratic equation in standard form. All right, that's all for task 3. If you have any questions, let me know.